Take a moment, look at your hand, feel your pulse, every beat, every breath, every thought. It's all powered by elements forged billions of years ago, in the hearts of dying stars. It sounds like science fiction, but it's pure, incredible science. The iron in your blood, the calcium in your bones, the oxygen you breathe, they didn't start on Earth, they started in the cosmos. You are, quite literally, made of stardust, and today on Chapter 10, we're going on a 10-minute journey to uncover the real story of how the universe made you. Our story begins in the very first moments after the Big Bang, roughly 13.8 billion years ago. In the beginning, the universe was incredibly hot and dense, filled almost entirely with just two simple ingredients, hydrogen and a smaller amount of helium. These were the only elements created in the Big Bang itself, but life, as we know it, needs so much more. It needs carbon, oxygen, nitrogen, iron, the building blocks of everything around us. So, where did these heavier elements come from? The answer lies in the universe's most efficient factories, stars. Imagine vast clouds of hydrogen and helium gas swirling in space. Over millions of years, gravity begins its relentless work, pulling these gases closer and closer, forming dense clumps. As these clumps grow, the pressure and temperature at their core become unbelievably intense, millions of degrees Celsius. It's at this point that a miracle happens, nuclear fusion ignition. Hydrogen atoms under this extreme pressure begin to fuse together, forming helium. This process releases a phenomenal amount of energy, outward, which fights against gravity's inward pull, stabilizing the star. This is the heart of every shining star you see in the night sky. For billions of years, like our own sun, these stars are cosmic furnaces, steadily transforming hydrogen into helium. This is the forge where the universe's most basic elements are transformed, but it's only the first step in our journey. But to get the really interesting elements, the ones that make up your very existence, we need something far more dramatic than a steady burning star. Not all stars are created equal. While our sun is a medium-sized star, some stars are truly enormous, many times more massive. These cosmic giants live fast and die young, and it's in their spectacular deaths that the building blocks of life are truly forged. These supermassive stars have cores so hot and dense that they don't just stop at hydrogen and helium, they can fuse heavier elements, helium into carbon, carbon into oxygen, oxygen into silicon, and eventually, silicon into iron. Iron is a cosmic dead end for a star. Fusing iron actually consumes energy, rather than releasing it. To truly understand the violence of a supernova, we need to talk about density. Right before the collapse, the star's iron core is shrinking violently. It becomes so dense that the protons and electrons in the atoms are literally smashed together by gravity to form nothing but neutrons. Think about that. The entire mass of that core, more than the sun, is crushed down into a sphere barely the size of a city. If you could somehow hold a sugar cube of this material, it would weigh billions of tons. This crushing creates an almost incompressible core of neutrons. When the outer layers of the star suddenly crash into this ultra-hard core, they don't stop, they bounce back with an explosive shockwave. This is the mechanism that drives the supernova and, crucially, provides the insane energy needed to finally create elements like platinum and gold, elements we literally fight wars over here on Earth, all thanks to a subatomic traffic jam billions of years ago. Once a massive star's core turns to iron, it's doomed. With no more outward energy pressure from fusion, gravity takes over with a vengeance. The core collapses in a fraction of a second, causing an unimaginable rebound, a catastrophic explosion known as a supernova. And here's the mind-blowing part. It's in this fleeting, violent moment, more powerful than billions of suns combined, that all the elements heavier than iron are created. The intense shockwave, the extreme temperatures and pressures, literally force atomic nuclei together, creating gold, silver, copper, iodine, zinc, and yes, even the tiny amounts of uranium found on Earth. These supernovae are the universe's ultimate element factories, seeding the cosmos with the ingredients necessary for planets and ultimately, for life itself. So, We have a universe sprinkled with these precious newly forged elements, but how do they get from a supernova remnant to, well, us? After a supernova scatters its riches across light years, these elements don't just disappear, they become part of vast, beautiful clouds of gas and dust, what we call second-generation nebulae. These nebulae are richer than the first, now containing not just hydrogen and helium but also carbon, oxygen, nitrogen, iron, and all the other heavy elements produced by dead stars. And guess what happens next? Gravity once again starts its work. These enriched nebulae begin to collapse, forming new stars. Our own Sun is one such second-generation star, formed about 4.6 billion years ago from a cloud that was already seeded with heavy elements from older, long-dead stars. As our Sun formed, the leftover dust and gas in the surrounding disk clumped together. These tiny cosmic particles, now rich with the stardust of ancient supernovae, slowly accumulated, growing larger and larger, eventually forming the planets we know today, including Earth. But the formation of Earth was only half the journey. For the stardust to become us, two elements in particular had to be abundant: carbon and oxygen. Carbon, forged in the helium-burning shells of medium-sized stars, is the ultimate scaffolding element. Its unique structure allows it to form long, complex chains, the backbones of DNA, RNA, and proteins. Without that stellar carbon, there is no way for life to build the necessary complexity. And oxygen, it didn't just form our breathable air, its ability to bond easily is what forms water, the universal solvent, and it's the primary component of most rocks and minerals on our planet's surface. A massive star had to live, die, and scatter its oxygen across the void just so Earth could have water and we could have the energy transfer system in our cells. Our existence is proof that the heavy elements from deep space arrived on time and in perfect quantities, ready to combine into the remarkable chemical machine that is the human body. And on Earth, over billions of years, these elements combined in incredible ways. The carbon became the backbone of all organic molecules. Oxygen formed our atmosphere and oceans. Iron became vital for transporting oxygen in our blood. Calcium built our bones and teeth. Every single atom of these heavier elements in your body, right now, came from inside a star, or from the cataclysmic explosion of one. It's an unbroken chain, billions of years long, linking you directly to the fiery hearts and explosive deaths of stars across the cosmos. So, the next time you look up at the night sky, remember this profound truth: you are not just on the universe, you are the universe, experiencing itself. Every atom in your body is a tiny piece of cosmic history, forged in extreme conditions, scattered across light years, and ultimately brought together to create you. It's a humbling, awe-inspiring thought, isn't it? This journey from a star's core to a human being is one of the most incredible stories the universe has to tell. If this deep dive into cosmic origins fascinated you, make sure to hit that subscribe button on Chapter 10 for more incredible stories from science, history, and beyond. Like this video to help others discover their cosmic connection, and share it with someone who needs to hear this amazing truth. Be sure to also check out our dedicated playlist, The Universe Files, for more videos on galaxies, solar systems, and everything in between. Thanks for watching, and keep looking up.